Thanks, Jim. That was, now I have to live up to that introduction. So as Jim mentioned, my name is Sanjeev Sharma. I work for Dell Technologies. So welcome to our hometown. For those of you who might not know, Dell was started here. We're headquartered, well, 20 minutes to an hour away, depending on traffic, right here in Round Rock, Texas. So welcome to our hometown. I'm fairly new to Dell. I've actually been at Dell for around 2 years. I lead the platform engineering team at Dell. I'll talk a little bit more about what we do and how we do it and why we do it. My background, I've been in this space for a long time. I stopped incrementing that clicker at 25 plus years. I refuse to increase that beyond that, but I've been in this industry for a while. Prior to Dell, I worked for a bank. I worked for Truist Financial. I was a part of the merger team, which brought in SunTrust and BB&T together. Prior to that, I was actually a Dell Fix employee. I worked in the CTO's office. I was de facto field CTO and used to work with a lot of the customers. I met some people here who I used to work with back then. And prior to that, I worked for IBM for over a decade and a half. And as Jim mentioned, I wrote a couple of books. I wrote the original DevOps for Dummies. There are several versions of this floating around. I don't think my version is available anywhere, but this was written 2013, so more than a decade ago, when DevOps was still forming itself, and people needed a For Dummies book. So that's kind of my background and history. So what do I do for Dell, right? So I lead an organization within Dell. We call it TechOps for short. We are the platform engineering team for all the engineers and software developers at Dell who make all these products you love, from laptops to servers to storage to networking gear to SaaS products. So it's a vast variety and a very broad spectrum of the kind of software that gets developed. It could be the BIOS which goes into your laptop, the embedded software that goes into a storage array. It could be the server management software to manage large fleets of servers in your data centers, to manage software-defined storage, software-defined networking, all the way to our SaaS platform by which you can do subscription management of Dell hardware and equipment which you might have in your data centers, or connect it to the cloud and run storage management or data protection software in the cloud. So it's a vast variety. It's thousands of developers spread globally. And like every organization, we needed a centralized team which could offer a set of services as a platform to these developers for the various use cases and workflows they have to develop the software and abstract away from them the complexity of dealing with the tools, the build processes, the pipelines, all the things which we talk about. And I have a slide in there talking about the various kind of services that go into a platform. So the TechOps team was created around 4 years ago, long before I joined, to provide that central service to all developers, and they could build, test, and deliver high-quality hardware, firmware, and software for all our customers' needs. So that's our mission: make our developers more productive and take away the abstraction of dealing with all the tools and services which they have to deal with in order to develop software from various vendors, right? We don't make our own tools. We get them from vendors like Perforce and several other partners of ours and put them together into a platform for our developers. So the concept of a platform, I can describe it, but I'll lead you to a book which actually has done probably the best job in describing how a platform should work, and more importantly, what a platform team should be doing. And that's a team by Matt Skelton and Manuel Paez called Team Topologies. They define a platform as being a curated experience for engineers to accelerate delivery for the teams that use it, right? So abstract away various complexities that will hold developers back and not allow them to do what you really hired them to do, which is to deliver a user experience by creating and testing and delivering world-class products. So this is the thesis on which we put our team together to say, we now want to deliver a platform. And if you look into your organizations, I'm sure if you don't have a central team that delivers developers a centralized platform as a service, the development teams have developed their own platforms with their own portals, with their own workflows, and created this in where we were also 2 years ago, a fragmented experience for various development teams. Having a centralized team allows us to give a curated experience for all the use cases and a common experience irrespective of what a developer is working on. So what is a platform made up of? It can get pretty complex. If you look at all the services a developer needs in order to build, test, and deploy, and validate what it is they are delivering and do it in a secure and compliant manner, there are several components to it. At the bottom, you see the environments layer, right? The infrastructure which developers are using to do their dev work, their test work, and in case you're running it in production, if you have a SaaS product, your production work. So you need all the services in order to manage the compute, the storage, and the network, and make it available to the developer as a service, so infrastructure as a service. The next layer above that is the application delivery layer. These are all the dev and test tools the developers use. And as you can see in the middle of it, something which got added not very long ago is Gen AI for developers, right? What are the Gen AI tools you're using to assist your developers in their process of developing and testing software? We use multiple tools in order to do that within Dell. Some of them are in the developer's IDE. Some of them are for knowledge management. But they allow developers to manage and make their pipeline, make their software development work easier. But at the end of the day, what you're delivering here is what you would be calling your CI/CD pipeline. Above that is where Delphix comes in, and tools like Delphix, which is in your data pipeline. How does a developer get data in a secure and compliant manner and abstracted away from having to be a DBA in order to be able to test and repeatedly test and retest their code? So those are the three layers. And we were actually had some roundtables yesterday, and we were talking about if you want to achieve continuous delivery and continuous testing, all these three layers need to be addressed. Otherwise, whichever one you don't address becomes a source of friction to keep you from delivering in a fast and consistent manner at a regular cadence. On the left, of course, is security and compliance. We live in a world where security and compliance is not a part of every aspect of what you do, you're going to have a very interesting story to tell in the Wall Street Journal or some other journal or some blog post somewhere, right? I remember talking to a CISO of a very large company recently, and I'm like, hey, what's your number one goal? He's like, nobody needs to know my name. I want to be incognito, and the only way they'll know my name is and what degree I got and where I studied and what my experience was if we have a breach and it comes to the forefront. So that's my number one goal. Nobody should know I exist. And the way to do that is not have the security team be solely responsible for security and compliance, but make that the responsibility of everybody. Having worked for a few years in a bank, I know the compliance first and risk-averse thinking some organizations have, especially if in a regulated industry. That needs to be embedded in your platform by giving developers guardrails which prevent them from doing dumb things. Because they will do dumb things, not intentionally and not because they are dumb, but because they are not experts in security and compliance. So, somebody made a comment yesterday, right, that the national parks have a huge problem. They need to make trash cans which humans can use, but bears cannot steal from. And the statement the national parks person made was that the overlap between the dumbest human and the smartest bear is a very large Venn diagram. So we have the similar situation where, developers need to be given guardrails which prevent them from hurting themselves by doing things they are not experts on, and then keeping your company secure and compliant and protecting you from developers getting you into situations where you don't want to be. So in order to have a platform like this, what we needed to do at Dell was create a platform team. There again, we went back to the team topologies book, and they said, OK, what should a development team look like? According to the team topologies book, your development organization, and if you look at your development organization, it will, even if you didn't intentionally do it, it is really made up of 4 types of teams. There is your stream-aligned teams. These are people who do your rote development. You're working on your sprints and your regular delivery, your regular cadence of developing, testing, and releasing software. There's complicated subsystem teams. These are usually SWAT teams you put together to go and solve complex problems. They're usually transient in nature. And then there's the platform team, which is delivering services. It might be a bunch of tool administrators who are delivering your GitHubs and your GitLabs and your Perforce tools and your other tools to your developers, or it might be a true platform engineering team. And then there is the 4th team is your enabling team, whose job is to train people and make sure they know what to do, so that developers, when they are onboarded, they know what your processes and procedures and compliance requirements are to develop. So our thesis was that the platform engineering team is actually just a recursion of this. That means the platform engineering team itself should have stream-aligned teams, enabling teams, complex subsystem teams, and a platform team which serves the platform team. And that's exactly how we have structured my team at Dell. So we have external services. Of course, these are services we receive from other parts of our company and from network providers and third-party data center services. Over that, we have our platform team. That's our core platform. They are the ones who run the infrastructure on which our tools and services run. And then we have teams, 3 types of teams. We have the technical engineering team. That's our complex subsystem teams. They go and handle, they are a high-touch team which goes and handles specific requests from particular teams saying, we need something unique. Now, given we also make hardware, that's very common at Dell, because it's not just a question of developing software which can run anywhere or be developed anywhere. We actually need to deploy prototypes of hardware which you haven't seen yet, right? Like the next set of servers which have the NVIDIA GB100 chips or the H200 chips. These are prototypes. We need to deploy those. So we have a special engineering team, which is our complex subsystem teams, which will go and deliver hardware to developers and make it available to them to develop software against and test for things which are still in the prototyping stage. Then we have the developer platform services. This is your regular CI/CD services, data as a service, build as a service, deploy as a service, integrate as a service, test as a service, which developers need to do their day-to-day work. The transformational team is our enablement team. Their job is to get developers off doing things the traditional way and get them to the platform and using the platform like we want them to. Other than that, on the left-hand side, you will see we have a security guild and an architecture guild. Those are all the security architects we have, security personnel we have, all the secure development pipeline people we have, and our architects we have, who get together regularly with developers to do best practice enablement. And, excuse me. And of course, on the right side, you can see business operations and business transformation. We are a global team. We like to say we are from Taipei to Tahoe. We have developers all across the globe and thousands of developers, so we have to have people who are managing our business of delivering a platform in a very comprehensive manner. On the top, you see a user engagement team. The way we treated ourselves is, hey, we are a company within a company. What does Perforce have to deal with you, work with all of you, the customers? They have a customer success team. They have a sales team. They have an enablement team. They have tech salespeople. I've created an internal team of that. They're like our internal DevRels and customer success folks who make sure the 13,000 developers we support understand what it is we are delivering to them, and we understand their needs and deliver what the developers really need in order to succeed. So this is what the team is structured like, and the goal is to deliver and abstract away the complexities of what a developer needs in order to succeed. Now, as I said, I joined Dell 2 years ago, and I've been leading this team for 2 years now. In fact, just finished 2 years a couple of weeks ago. So let's take the rest, the 15 minutes or so I have to talk about what has been the journey so far. Right? 2 years is in technology times an eternity. But if you're talking about working with a large company with thousands of developers, which doesn't change very easily, like most large organizations, it is a very short period of time to really have an impact. But we truly believe we have had an impact. So just like I mentioned earlier on, all organizations, developers, if left alone, are going to build a platform of their own. They're going to find a way to abstract away all the tools and services which they need, which might even be delivered to them from a centralized team, and convert it into a way which is consumable by them. So what we found at Dell was that our development teams had built hundreds of portals across the company. They had built hundreds, in fact, thousands of scripts which were integrating their tools which we were delivering to them from a centralized team, though not yet a platform team, and created their own pipelines which they could instrument via APIs. These were essentially, it might be as simple as a YAML file which calls a bunch of APIs to put a tool together, or might be a Jenkins job or some kind of a CI tool, a GitHub action which goes and invokes different services from the various tools and capabilities we have to something more complex, like an actual portal they built where developers can go and invoke these services, building their own mini SaaS. Before I got there, our platform team, the central team, had also started building platforms. But they ended up building 3 platforms. They built a pipeline platform by which developers could come and compose their CI/CD pipelines. They built a test and test data management platform where developers could come and manage their test environments, their test scripts, do their test configuration management, and as needed, the test data management. And then there was an infrastructure management platform because we have, I won't go into details, but we have tens of thousands of servers and storage arrays in data centers around the world, which we use for testing purposes. Most of these, as I mentioned earlier, are prototypes, which we are testing on to either develop the prototype itself or develop the software on top of the system before we grow. So we had this fragmentation of 3 centralized platforms and hundreds of homegrown mini platforms which development teams had developed. So a year and a half ago, we said, okay, this is not working. We have a centralized platform team. We need to build a centralized platform. So we call it Nexus internally. It's our internal development platform. We support both software engineers and our firmware engineers and also our hardware engineers through that platform. Now, hardware engineers, obviously, they want a server on a bench where they are, doing thermal testing or swapping out components. So the services we offer to them are more hands-on because you're working inside the chassis of the hardware appliance you're working with. Whereas for the software and firmware engineers, we are working outside the chassis. They're looking at the entire server chassis or storage chassis being deployed somewhere, and they are accessing it either physically or remotely. The idea here is that through this platform, we are able to give developers full stack management. There are 4 tenets we came up with and said, these are the tenets which we need to be able to deliver to our developers. First and foremost, it should be self-service. They shouldn't need to open a Jira ticket or a ServiceNow ticket in order to get anything done from the platform. Today they need to, but eventually we'll get to complete self-service. Number 2, pipeline should be composable. Given we have such a wide spectrum of software types we develop from embedded software and firmware all the way out to SaaS, the workflows the developers use varies. The way you develop firmware and test firmware is very different from the way you develop a SaaS tool. So we needed the developers for these pipelines to be composable so developers could compose them for the various types of workflows they have rather than us trying to compress them. Now, we want to reduce the number of workflows, but still, we've at least these 4 personas we have of embedded software, software which is embedded or built for a purpose-built appliance, or software which can run anywhere, including an EC2 instance in the cloud, or SaaS. These are kind of the 4 broad personas. We want to at least be able to support composable pipelines for these 4 broad personas which we support. As I mentioned, it has to be full stack management. We don't want people to need to go outside the platform to get any service like they needed to beforehand, go to 3 different platforms. And of course, we are also wanting to standardize more. So we've come up with standardized branching requirements, right? Branching techniques to say, okay, this is what your Git branching ought to look like. And these are the 3 types of branching structures you can use. You can't use a 4th. Same way we've developed playbooks to say, okay, Mr. Developer, you developed your own testing harness. We'll allow you to publish it in our platform so that the entire team can use it. So we use an inner source model. We are the maintainer. You might be the maintainer of that software, and we might be a contributor. But we set the guidelines by which you can publish that software onto our platform. So we've engaged developers by using this inner source model so they can contribute Cure to the platform because over the years, as I mentioned, they've developed hundreds of these composite portals and composite platforms for their needs. We don't want that to be throwaway work, but we are constraining the variations that they can bring in so that we're getting more and more standardized. So let me end with this, right? 7 keys. Why did I come up with 7? There's a 7 habits book. I don't know, 7 seems to be a good number. People keep doing 7 this, 7 that. Every blog post writer seems to have a 7 something, so I did 7. If that night when I was making this slide, I thought of 8, I'd put 8. But I stopped at 7. So number 1, and hopefully we'll have time for Q&A also. I think I have 10 minutes plus left. So number 1, standardization is critical. Right? Standardized tools. You can't have people using 5 different types of tools for the same function. Yes, there might be more than one type of tool. For example, when I worked at at Truist. By the way, come later to listen to my friend Preetham's talk on what they're doing with Delphix at Truist. Preetham was a part of my team back there, so brief commercial break to promote his talk. I see him right up front here. He'll be speaking later today. So standardization is critical, right? I mean, back when we were at Truist together, we couldn't standardize. We wanted to standardize, but banks use a lot of mainframes. So there was a separate set of tools for mainframe versus distributed. But there shouldn't be 15 different tools. Standardized processes, standardized RACIs, right? Roles and responsibilities. What do developers do versus what does the platform team do? And there can be no exceptions, but as I said, exceptions-ish, because there'll always be a unique case. There'll always be some team which says, you know, I develop something so unique that I have to get an exception from the standard. Number two, are you having impact? This is really probably, I think, the most difficult problem. How do you know it's worth it? So if you have hundreds of people, engineers and developers who are working for the platform team, which we have today, the constant question we get is, I can take those 800 people who are managing labs and supporting these 13,000 developers and use them to build a new product which can bring the company billions of dollars. Is this worth having this platform engineering team? How do you measure that success? The biggest challenge with that is most people start with no baseline. Like my team had started long before I got there, but they never did any baselining to say, okay, this is what developers do today, this is what they spend time on today, let's see if we can make them more productive. We didn't have a baseline, but we created a baseline from wherever we were and said, now we got to show improvement. We got to show developers are spending less time dealing with tools, with data management, with security, because there is a platform. Number three, engage developers early. So one of the things we did pretty early was, at least when I started, was we created what we call a partner advisory board. This is like your customer success board, right, which you might have if you're a vendor, where we said every product team send us a developer, a senior developer who knows what you do and how you do it, and is highly opinionated, right, the worst nightmare of ours. Send them to this team, let's put them on the partner advisory board, and we will run by everything we do by them and get input from them, help them prioritize what we should be doing and not doing. The advantage of that is they have no skin in the game. They are engaged from day one, right? Because otherwise we were building stuff and nobody was coming. Our test and test data management platform, guess what? Nobody was using it, although we had built it. Because we never engaged the developers early enough, the testers early enough to say, is this what you really need? Number four, use security to attract developers. One thing developers hate doing is managing security. So if you can automate security things by the guardrail things I was talking about earlier, they will come. If I can introduce automatic patching of their VMs which they're developing in via the platform, and that's the only way you get it, guess what? They log into the platform every day to say, these new CVEs, I need to patch my VMs for them. Here's some automation. Let me go to the platform. So security and compliance is an easy way to attract developers. Engage developers continuously, right? Just that PAB model, the partner advisory board model or security is not sufficient. How do you make developers a part of the platform? As I mentioned, we are using the inner source process by which we are the maintainers and developers can contribute code, or they can give something they created and they be the maintainers and we contribute code to them, and we give them a way to publish that code and make it a part of the platform. Number six, make it easy to use. Developers don't want to learn new stuff. They love continuing doing work the way they've been doing. They hate change, right? They do not want to change. You get a developer to switch from GitHub to GitLab, they'll complain. You want them to switch from VS Code to another IDE, they'll complain. No matter what change you do, they'll complain. So the idea is that you make it as easy, self-service and zero-touch migration. That was our number one goal. If developers have a portal, we will consume it and make it look like the same within our platform. And over time, we'll deprecate it and move them to the UX and developer experience we want them to have. But if we make it easy for them, make it, they go to their old URL and suddenly they're in our platform, and the look and feel seems familiar, it'll be easier for them to make the transition. And last but not the least, happy developers are productive developers. At the end of the day, it doesn't matter whether a developer is more productive, less productive, generating 20% more code, 30% less code. At the end of the day, if you survey them, and we do a lot of surveys to measure NPS, are they happy? Are they happier today than they were before they started using the platform? Do they feel that it is adding value to them? That perception matters actually more than the metrics. So we keep measuring that over and over again to make sure, are we doing the right things? Are we making our developers successful? Are we reducing friction by making data easier to access for them? Are we reducing friction and risk by masking the data and making it available to them in a manner that they don't need to worry about, hey, I'm using this test data, it's a clone of production. Can I be making, what do I need to do to secure it? Well, if we can tell them the data is all masked, they don't have to worry about anything. They can just use the data, use it 100 times, throw it away, delete it, bring it back and put it in the cloud. It's no longer their problem because we took away that risk for them. That makes them happy. I wanted to end with the old Microsoft CEOs, developers video. How many of you have seen that before? Some of you are, some of you are too young to know what I'm talking about. But I figured I'll just leave it there. At the end of the day, our job is to serve developers, right? And as a platform engineering team, our basic goal is to make developers' life easier. And how we do that is by taking away the complexity, reducing the friction they face doing their job, and all the other things they need to do their job other than developing and testing and delivering code. How do we take that complexity, that friction away? That's our goal, and hopefully this will be useful to you and your teams as you work towards making your developers more productive. Thank you for your time, and I hope you have a great conference. I'm around all day. If anybody has any further questions, I'll be happy to address, and I'd like to thank Delphix and the Perforce team for allowing me to share with you. So thank you, everybody.